Okay, so in the second part, we will look at some more challenges. But before going into the challenges again, let us see a concrete implementation and see how these challenges are coming in front of us. So let us take an example for a smart home implementation where the sensors, they have identified the sensors. You can see here this motion sensor is used to find out any people movement inside the room. So that will help you to check whether the room is vacant or not. If the room is not occupied by any person, it's okay if you switch off all the lights, AC, television, etc., and you can reduce the power consumption. Next one, what you see is door control, the automatic opening, closing, secure locking of the door. And then environmental monitoring. So what is the air quality here? Is there any poisonous gas? Any bad smell is coming, etc. Everything will be, the environment will be checked. And this is about the comfort, heat, ventilation and air conditioning. Sensor is there. It continuously monitors the humidity, temperature level of the room and ensure maximum comfort to the people. And here you can see the lights, the intensity of the light, color, everything can be changed to bring a proper mood in the room, because we know that lights can affect our mood. So the lights can be configured to such an extent that they gives the required color or the tone of lighting for the mood that you are currently in. And moreover, when you watch the television, the ambient lights plays an important role in reducing the strain on your eyes. Let's say these lamps were too bright, then if you look at this television screen, your eyes will have problem in segregating the light which is coming at a high intensity than the television. So light control, even though it appears to be very simple, you may think that okay, I'll switch on the light and switch off the light. That is not enough. There are various other options that has to be thought of. And you have a set-top box which is actually streaming the video onto the television. So you have a lot of options. You could have a network-based streamer which is capable of receiving videos from most of the devices, AirPlay, a lot of stuffs coming here that has to be integrated. And you have a remote. Nowadays the remote has support for Google Assistant, so the remote is not the usual IR remote. Now you might have understood the smart set-top boxes or TVs are having Bluetooth based or Wi-Fi based remote control. They do more than just a normal device, Bluetooth. And you have window control, opening, closing, etc. So all these things we need to implement. So we will go for sensor selection and then implement it one by one. So let us see how this can be done. So a typical setup using Raspberry Pi as a central processor is shown here. So you have, as we learned in the previous lecture, a relay which controls the bulb, and you have an SD card with Linux for booting up this machine, and the power adapter and Wi-Fi is connected, the cloud. So let us consider such a setup for this smart home. So what are the issues that arises if we go with this kind of setup? So let us compare and contrast before selecting Raspberry Pi for this operation. So if you look at this, the Raspberry Pi requires power. You can power it from a power bank or a battery pack, or you can connect it to a wall outlet. Both has its own merits and demerits. So these are the two means. Next thing, let us look at the wireless interface that we want. You have to decide based on the data rate, how many bytes do we need for controlling the light, what is the Wi-Fi speed, so what would be the overhead for transferring a small packet. Everything has to be thought of, because some protocols are very much heavy. That means their header and tailor part will be much more larger than the actual payload. For example, HTTP. Let's say we are transferring 1 byte with HTTP. HTTP header itself has got more than 20 bytes of header. So HTTP is not an option if your data to be transmitted is very small. So the overhead for transmitting is of prime concern. Next, how much processing speed do I need? That's another question that needs to be answered. So faster processor tend to use the battery faster. So there should be some compromise made there. So can a delay of a millisecond be tolerable? That's another question. So what is the level of accuracy of operation? Is it millisecond or microsecond? So if it is a mission critical operation, you will have to pay an error that is of the order of a millisecond or a microsecond. So it all depends on the application where we use this project. Now, can we use Linux? What OS should be there? Or should we use an OS, or can we run on the bare hardware? That is a question. To use or not to use an OS, that's another question that we need to answer. So let us see that in practice. So if you put a tabular column and list the requirement, CPU, memory, data rate, etc., and look at the different options in front of you. As an exercise, you can extend this for Node MCU and Arduino. Okay, so this could be one activity for today. So extend this table for Arduino or Node MCU. You can draw one more column here, and the first column you put Arduino and next column you put Node MCU, and see how it does. Okay, so this is the activity for today's lecture. We will ask you to demonstrate it in your notebook and show it if required. So if we look at this implementation, PC is nowhere in the picture because it has got too much of power consumption, and smartphone and Raspberry Pi seems to be attractive. But even though if you use a Raspberry Pi, let's say we have 100 such room in a big hotel or 50 such room, so how many batteries you will have to replace a day? So you'll have to employ a person whose job will be to check and replace the battery. So that you have to think about it, how much practical it is. Okay, charging and replacing batteries. So in this way, the challenges will stop you from doing actual IoT business. And you have this wireless sensor also coming in. It has its own issues. So this is a kind of Node MCU type of board which you can power it from battery. So that's about the challenges, and hope you understood the how challenges are playing a major role in coming up with a design. So next class we will look at the protocols and how it could be used. Now it's almost 10 minutes of lecture. So there will be a short quiz posted in the Emble which you can answer if you have watched the videos carefully. So in the next class we will look at the standards. Standards majorly come from protocols. So we will look at what is standard and how it will be used. So IoT standards, people say that they are like toothbrushes. That means every company comes with a standard of their own, but there is no common standard. Now at the end of the day, you will be writing drivers or bridges that will connect one standard to the other standard, and there will be another set of bridges that connects one bridge to the other. That is how IoT is going about right now. So there is no globally accepted standard, but still we can see some of the standardization attempts from the side of Cisco, IBM in their applications. So we will have a look at them in the next class. So today we will wind up by taking up the quiz, and also you can have any discussions based on the lectures that we have. So you need to look at the lectures in such a way how these lectures help in your use case implementation. That should be your target. Thank you. We are concluding here.